Hello everyone, this is Mr. Taylor. I would like to take a look now at graphing reductions. This is also a transformation, a form of a dilation, but reduction means that the actual image will get smaller than the pre-image. Our learning objective is that you will find points on a dilated image by multiplying the x and y coordinates of the original figure by the scale factor, which will create a reduction. The vocabulary that you need to get out of this one is the same as the other ones in lesson 13 with the exception of reduction. And when we look at Explore Activity 2, uh, the author says for scale factors between 0 and 1, so that means these will be numbers that are assigned to be fractions or decimals, the image is smaller than the pre-image. And this is called a reduction. So what we have presented to us here is a figure that's to our right here. And this figure is literally, if we look at it, this figure is the pre-image or the original figure, and it says the center of the dilation is the origin. So what it wants us to do is just like we did with the enlargement, it asks us to list the coordinates of the vertices of the pre-image in the first column, then determine what is the scale factor and apply the dilation to the pre-image and write the coordinates of the vertices of the image in the second column, and then it asks us to sketch it over here. So if you would like, you can go back to the other uh, video and refresh your mind, but here let's go ahead and stop it. Look at what it says that our pre-image is, and then this is what they're asking us, that k is 1/2, and apply k to x and apply 1/2 also to y. So you can stop it and come back when you're done. Okay, we can start anywhere with this. And the way I see is I'm going to start at the origin and I'm going to go up to the point of the arrow. So I see 1, 2, 3, 4, 5. So that means I'm at 0 for x. I'm at 0 for x and 5 for y. That's my original. And if I multiply 1/2 times 0, so remember we're doing 1/2 times 0, comma 1/2 times 5. So that's how we're going to get our image. And then of course 1/2 times 0 is 0, and 1/2 times 5 is 2.5. So that's how we get our first one. The next one, if I take a look, I might want to go and this is you choose how you want to find your vertices. So I might want to go 1, 2, and then to this particular point. So I'm going to the right 2, which is positive for x, and then up 2. So I'm looking at roughly 2, comma 2. And if I multiply just like I did up here, 1/2 of 2 is 1, and 1/2 of 2 is 1, and then that's how I get my actual image. Then if I want to take and go to this point, I want to do 1, 2, 3, 4. So my x is 4, and again I'm going up 2, so I'm looking at 4, comma 2, and 1/2 of 4 is 2, and 1/2 of 1 is 1. So that's my next. Now I might want to staying in the positive side for x. I might want to take this one, so I would go 1, 2, and down 1, 2, 3, 4. So x is going to be positive. It'll be 2. I want to put my Go ahead and take that out right quick. So again, x is going 2, and here y is 1, 2, 3, 4. So it's a -4. Okay, so now let's start with this side for the negative part of x, and let's go to this one. So I see x is a -1, -2, and y is positive for y, 1, 2. Okay, let's go ahead and finish this out. 1/2 of 2 is, of course, 1, and 1/2 of a -4 is a -2. Don't forget those signs. Make sure your signs are correct. So here I'm looking at 1, 2, 3, 4, a -4, and up 2, and up 2, and then of course 1/2 of a -4 is a -2, and 1/2 of 2 is 1. Let's go back up here and complete this one. 1/2 of a -1 is a -1, and 1/2 of 2 is a -1, and 1/2 of a -2 is a -1. Kind of get my bearings together here, and then 1/2 of 2 is 1. And then of course the last one is we're going to go over 1, 2 to the left, so that's going to make x a -2, and y is going down 1, 2, 3, 4. So y also is a negative, but it's a -4, and then we can take 1/2 of a -2. That's going to give us a -1, and 1/2 of a -4 is a -2. Okay, so now, and of course you might have started at a different area, which is fine. And then the only thing we're doing now is you're looking at, and let me go back up here and put this one in. Once we saw how we did the math, I just want to show you how we would do the math. So I'm looking at here I'm looking at 0, 2.5. Okay. So what is a scale factor? Well, we multiplied the pre-image by 1/2. So if we multiplied every single vertex by 1/2, then of course the scale factor is 1/2. Then it asks us to apply the dilation to the pre-image and write the coordinates of the. Now let's go back. You could have also, or you could have wrote 0.5. That's all the same. And it asks us to apply the dilation to the pre-image and write the second coordinates in the table. We done that. And it says sketch the image. Now, how does the dilation affect the length of the segment lines? And how would a dilation with a scale factor of 1 affect the pre-image? Think about that for a minute and then come back and give me your assessment. Okay, so here's what we have. It says if coordinates, these are the same exact coordinates that I got. They started at different points. Scale factor of 1/2, and notice that because of the is being about the origin, notice that it's smaller and it's inside the original figure. Okay, now how does the dilation affect? So remember we said about the circle and about the figure that we did previously. It affects it according to the length. It affects the length according to the scale factor. So the scale factor is 1/2. The image length is 1/2 of the pre-image. And then it says, well, what if you had a scale factor of 1? That means that if I have, say, x comma y, and x is 7 comma y is 10, and I have a scale factor of 1, so that means that's going to be 1 times x comma 1 times y. Well, 1 times 7 is just 7, and 1 times 10 is 10. So the actual image and pre-image would definitely be the same. So that's why we say greater than 1 creates the enlargement, and less than 1 creates the reduction. Okay, that'll do it. Thanks for watching.